Hello everybody, welcome into another lesson. So today we are going to discuss monomial factors of polynomials. So we are beginning our factoring unit here. So to factor, you got to look for what do each of these terms have in common. Start with your constants again. Between 15, 25, and 20, what constant do they all have in common? Definitely a 5. Okay, they got a 5 in common. Now, do they have any variables in common? No, they don't. Once you've established what they have in common, you're going to put a parenthesis. Now, you're going to basically do a distributive property through each term. 5 times what equals 15a? 3a. 5 times 3a equals 15a minus 5 times what equals 25b? 5b plus 5 times what equals 20? 4. And this reduces no further, so the answer you should get is 5 times the quantity of 3a minus 5b plus 4. So once you establish what each term has in common, you put that outside the parentheses, and then you just multiply what it has in common by whatever number or variable you need to get the terms that you originally had. And we'll go over some more examples here. We have 18x minus 12y plus 36. Alright, so we got 18x minus 12y plus 36. Look at your constant first. What do 18, 12, and 36 have in common? They have a 6 in common. 6 is a common factor of all three, 18, 12, and 36. So 6 will start what's outside your parentheses. Now, are there any variables in common? There are not. So you're done with what they have in common. Now you're going to do your parenthesis. 6 times what equals 18x? 3x. Minus 6 times what equals 12y? 2y. Plus 6 times what equals 36? Well, that's 6. So the answer you should get for this would be 6 times the quantity of 3x minus 2y plus 6. Alright, we got 6x squared plus 10x. So now we have something like 6x squared plus 10x. Well, start with your constant first. 6 and 10 have what in common as the greatest common factor? That'd be 2. Alright, so we've established that part. Now, do they have a variable in common? They do. They both have a common x. So 2x will go on the outside of your parentheses. And that's all you have. That's all they have in common. Now we need to deal with the original expression. So 2 times what equals 6? 3. X times what equals x squared? X. So we have 3x plus 2x times what equals 10x? 5. And these factor no further, so the answer you should get would be 2x times the quantity of 3x plus 5. That would be your factors. Alright, we have 14c cubed minus 21c. Well, again, start with the constants. What do 14 and 21 have in common? They have a 7 in common. Do they have any variables in common? They have a c in common. So 7c would be your factor, the common factor for both. Now, 7 times what equals 14? That'd be 2. C times what equals c to the third? That'd be c to the second. Minus 7c times what equals 21c? That'd be 3. And for now, we can't factor any further, but as we get later into Algebra 1 and into Algebra 2, we will be able to factor the 2c squared minus 3. That actually does factor further, but for now, that answer would suffice because we haven't learned how to do that just yet. I will teach it to you, though, when the time is right. Alright. We have 6p squared q minus 9pq. So we got 6p squared q minus 9pq. Well, start with your constants. 6 and 9 have what in common as their greatest common factor? That'd be a 3. Okay. Do they have any variables in common? Well, both p and q are common because you have p squared in the first term and p in the second term, so p is common. And then you have q on each term, so the q is also common. So 3pq is your greatest common factor. Now, do your parentheses. 3 times what equals 6? That'd be 2. P times what equals p squared? P. Q times what equals q? 1. So we're good with 2p minus 3 times what equals 9? 3. P times what equals p? 1. So we're good there. Q times what equals q? 1. So this factors no further. The answer you should get for this would be 3pq times the quantity of 2p minus 3. That'd be the answer you get. Alright, let's see. We got 2a squared b squared plus 10ab. Alright, so we got 2a squared b squared plus 10ab. Well, start with your constants. What do 2 and 10 have in common as the greatest common factor? Definitely 2. Now, do they have common variables? Well, they have an a in common between a squared and a. They have an a in common. Between b squared and b, they also have a b in common. So, 2ab is your greatest common factor for each of these terms. Now we need to deal with our parentheses. 2 times what equals 2? 1, so we don't even got to write it. A times what equals a squared? That'd be a. B times what equals b squared? That'd be b. Alright, so we've dealt with the first term, plus 2 times what equals 10? That'd be 5. A times what equals a? 1. B times what equals b? That'd be 1. So the answer you should get for this would be 2ab times the quantity of ab plus 5. Alright, we got 7y to the third minus 21y squared minus 14y. Alright, so we got 7y to the third power minus 21y squared minus 14y. Well, let's look at each of these constants first. What is the greatest common factor of 7, 21, and 14? Definitely 7. They have a common 7. Now how about the variables? Well, you got y cubed, then y squared, then y. They all have a common y. So 7y is your greatest common factor of these three terms. You've established that. Now you need to form your parentheses. 7 times what equals 7? Just 1, so we don't even got to write that. Y times what equals y to the third? That'd be y to the second. Minus, then we got 7 times what equals 21? 3. Y times what equals y to the second? Well, that'd be y. Then you got 7y times what equals 14y? That'd be 2. So the answer you would get for this would be 7y times the quantity of y squared minus 3y minus 2. Alright, how about, let's see, 22 y to the fourth minus 33 y to the third plus 11 y to the second. Alright. So we got 22y to the fourth minus 33y to the third plus 11y to the second. Look at your constants. What is the greatest common factor of 22, 33, and 11? Definitely 11. So we got that. Now between y to the fourth, y to the third, and y to the second, what's your greatest common factor of those three variable expressions? Definitely y to the second. So your greatest common factor of these three terms is 11y to the second. Now you're going to form your parentheses. 11 times what equals 22? That'd be 2. Then y to the second times what equals y to the fourth? That'd be another y to the second. Alright, minus 11 times what equals 33? Well, that'd be 3. Then y to the second times what equals y to the third? Just y. Plus 11 times what equals 11? Just 1, so we don't even got to write that. But you got y squared times what equals y squared? Just 1. So, yeah, you'll end up writing the 1. It would have been 1 times 1, which would just be 1. So, the answer you should get for this would be 11y squared times the quantity of 2y squared minus 3y plus 1. Alright, let's see. 6a b to the second minus 8a to the second b. So we got 6ab to the second minus 8a to the second b. Well, start out with your constants. 6 and 8 have what as the greatest common factor? That'd be 2. Alright, a and a squared have what is the greatest common factor? A. B squared and b have what is the greatest common factor? That'd be b. So we've established that your greatest common factor of these two terms is 2ab. Now you form your parentheses. 2 times what equals 6? Well, that'd be 3. A times what equals a? That'd be 1, so we haven't got to write that. B times what equals b squared? B. Minus 2 times what equals 8? That'd be 4. A times what equals a squared? That'd be a. B times what equals b? That'd be 1. We don't even got to write that. So the answer you should get for this factor would be 2ab times the quantity of 3b minus 4a. Alright, let's see. 4x squared y minus 16xy squared. So we got 4x squared y minus 16xy squared. Start with your constants. 4 and 16 of what is the greatest common factor? Definitely 4. Now x squared and x, between those two, what's the greatest common factor? That'd be x. Between y and y squared, what's your greatest common factor? Definitely y. So 4xy is your greatest common factor of these two terms. Now that you've established that, form your parentheses. 4 times what equals 4? That'd be 1. You don't got to write that. X times what equals x squared? X. Y times what equals y? 1. So we don't got to write that because it would have been 1 times x times 1, just leaving you x. Minus 4 times what equals 16? Well, that'd be 4. X times what equals x? That'd be 1. You don't need to write it. Y times what equals y squared? That'd be y. So your answer to this would be 4xy times the quantity of x minus 4y. Alright, negative 15 x squared y squared minus 6x y squared. Alright, so we got negative 15x squared y squared minus 6xy squared. Well, let's establish what they have in common. Definitely a negative. They both have a negative in common because they're both negative terms. Now 15 and 6 have what in common as their greatest common factor? A 3. So you got negative 3 so far. Now between x squared and x, what's the greatest common factor? That'd just be x. And then you got y squared and y squared on both terms, so y squared would be a factor. So your greatest common factor is negative 3xy squared. You'll take that and times your parentheses. Now negative 3 times what equals negative 15? That'd be positive 5. And then x times what equals x squared? X. Y squared times what equals y squared? That'd just be 1. We don't got to write it. Alright, so let's see. Negative 3 times what equals negative 6? That'd be positive 2. So in the parenthesis you'll have plus 2. Then we got x times what equals x? Just 1. Y squared times what equals y squared? Just 1. So the factorization of this should be negative 3xy squared times a quantity of 5x plus 2. Alright, negative 16 x cubed y minus 24 x to the fourth y to the third. So we got negative 16 x cubed y minus 24 x to the fourth y to the third. Well, let's look for what the constants have in common. There's definitely a negative 1 in common, or a negative sign, so that'll start it. Now between 16 and 24, what's the greatest common factor? That'd be 8. So far you got negative 8. Now between x to the third and x to the fourth, what's your greatest common factor? That'd be x to the third. And then between y and y to the third, what would be your greatest common factor? That'd be y. So it looks like your greatest common factor of these two terms is negative 8x cubed y. Take all that times your parentheses. Negative 8 times what equals negative 16? That'd be positive 2. X to the third times what equals x to the third? Just 1. Y times what equals y? Just 1. So we got 2. Now negative 8 times what equals negative 24? That'd be positive 3. Then x to the third times what equals x to the fourth? Just x. And then y times what equals y to the third? That'd be y to the second. So the factorization of this problem should be negative 8x to the third y times the quantity of 2 plus 3xy squared. If you take it piece by piece, it's not so bad to factor these. That's the key. Take it piece by piece. Break it down by your constants, then each variable. Alright. 5ax squared plus 10a squared x minus 15a to the third. So we got 5ax to the second plus 10a to the second x minus 15a to the third. Start with your constants. 5, 10, and 15. What's the greatest common factor? Definitely 5. Pick apart each variable. Between a to the second, and a to the third, what's your greatest common factor? That'd be a. Now, not all three terms have an x term, so we can't factor out an x. All three terms would have to have one. So your greatest common factor for these three terms is simply 5a. Now you're going to form your parentheses. 5 times what equals 5? 1. A times what equals a? 1. 1 times what equals x squared? Just x squared. Plus, we got 5 times what equals 10? Well, that'd be 2. A times what equals a squared? That'd be a. 1 times what equals x? That'd be x. Minus, we got 5 times what equals 15? That'd be 3. A times what equals a to the third? Well, that'd be a to the second. So for now, this is all we can do. In the future, we'll be able to factor further, but for now, this will suffice. 5a times the quantity of x squared plus 2ax minus 3a squared. Actually, in the not too distant future, we'll be factoring quadratic equations like that. Alright, we got 14 p to the third, q to the third, minus 21 p to the second, q to the second, plus 35 pq. Alright, so 14 p to the third, q to the third, minus 21 p to the second, q to the second, plus 35 pq. So start with your constants, or your coefficients, excuse me. Your coefficients. So 14, 21, and 35 have what number in common as their greatest common factor? Definitely 7. Now between p to the third, p to the second, and p, what's the greatest common factor? Definitely a p. Between q to the third, q to the second, and q, what do they have in common? Q. So it looks like your greatest common factor of these three terms is 7pq. Now form your parentheses. 7 times what equals 14? That'd be 2. Then p times what equals p to the third? That'd be p to the second. Then q times what equals q to the third? Well, that'd be q to the second. Minus 7 times what equals 21? That'd be 3. P times what equals p to the second? That'd be p. Q times what equals q to the second? That'd be also q. That'd be q plus 7 times what equals 35? Well, that'd be 5. P times what equals p? 1. Q times what equals q? 1. So we've factored as much as we can for now. So the complete factorization of this polynomial is 7pq times the quantity of 2p squared q squared minus 3pq plus 5. Four more examples, then we're done. 48 a to the third b to the second plus 72 a to the second b to the third. Alright, so we got 48 a to the third b to the second plus 72 a to the second b to the third. Well, between 48 and 72, what's their greatest common factor? That'd be 24. Okay? Now between a to the third and a to the second, what's the greatest common factor? That'd definitely be a to the second. Between b to the second and b to the third, what's the greatest common factor? Definitely b to the second. So your greatest common factor of these two terms is 24a squared b squared. Now you form your parentheses. 24 times what equals 48? Well, that'd be 2. A to the second times what equals a to the third? That'd be a. B to the second times what equals b to the second? That'd just be 1. So we've completely factored that. Plus 24 times what equals 72? Well, that'd be 3. A to the second times what equals a to the second? That'd be 1. B to the second times what equals b to the third? Well, that'd be b. So the complete factorization of this problem would be 24a to the second b to the second times the quantity of 2a plus 3b. Alright, 3 more. 77 r to the 7th s to the 7th minus 84 r to the 8th s to the 4th. Alright, so we got 77 r to the 7th s to the 7th minus 84 r to the 8th s to the 4th. So first start with your coefficients. 77 and 84 have what as their greatest common factor? Definitely a 7. Now, r to the 7th and r to the 8th, what's the greatest common factor? Definitely r to the 7th. Now between s to the 7th and s to the 4th, what's the greatest common factor? Definitely s to the 4th. So the greatest common factor of these two terms is 77 r to the 7th s to the 4th. Now you'll take your parentheses, so all this times your parentheses. 7 times what equals 77? 11. R to the 7th times what equals r to the 7th? Well, that would just be 1. So s to the 4th times what equals s to the 7th? That'd be s to the 3rd. Alright, minus 7 times what equals 84? That'd be 12. R to the 7th times what equals r to the 8th? That'd be r. S to the 4th times what equals s to the 4th? That'd be 1. So the answer to this factorization would be 77 r to the 7th s to the 4th times the quantity of 11 s to the 3rd minus 12r. Two more, then we're done. Alright, they're throwing it at us for the last two examples. Got 96 wx cubed y to the second z to the second minus 144 w to the third x y to the second z to the second. Yep, they really hit us on this problem. We got 4 variables with these constants. So start with your coefficients first. 96 and 144 have what is their greatest common factor? And feel free to use a calculator if you need. But I can tell you it's 48. 48 is your greatest common factor of 96 and 144. Now between w and w to the third, what's your greatest common factor? That'd definitely be w. Between x to the third and x, what's your greatest common factor? That'd be x. Now between y squared and y squared, what's your greatest common factor? Definitely y squared. Then between z squared and z squared, what's your greatest common factor? That'd be z squared. So the greatest common factor of these two terms is 48wx y squared z squared. Now you form your parentheses. 48 times what equals 96? That'd be 2. W times what equals w? 1, so don't worry about that. X times what equals x to the third? That'd be x to the second. Y to the second times what equals y to the second? That'd just be 1. Z to the second times what equals z to the second? That'd just be 1, so we're done there. Minus, then we got 48 times what equals 144? Well, that'd be 3. Then w times what equals w to the third? That'd be w to the second. Then x times what equals x? That'd be 1. And then we got y to the second times what equals y to the second? That'd also be 1. Z to the second times what equals z to the second? That'd be 1. So we can go no further. The greatest common factor of this, or the complete factorization rather, is 48wx y squared z squared times the quantity of 2x squared minus 3w squared. And I do have one more problem. (84a) b to the second, c to the third, d to the fourth, plus 126 a to the fourth, b to the third, c squared. Alright. Last problem. So we have 84a, b to the second, c to the third, d to the fourth, plus 126, a to the fourth, b to the third, c to the second. Alright. Start with your coefficients. 84 and 26 have what in common? I could tell you it's 42. That's the greatest common factor of those, will be 42. Now, between a and a to the fourth, what do they have in common? Definitely an a. Between b to the second and b to the third, what do they have in common? B to the second. Between c to the third and c to the second, what do they have in common? That'd be c to the second. Now, the first term has a d to the fourth, the second term has no d whatsoever. So we can't do anything with the d to factor out. So we've established our greatest common factor being 42ab to the second, c to the second. Now we can form our parenthesis and start with each term. 42 times what equals 84? Well, that'd be 2. A times what equals a? That'd be 1. B to the second times what equals b to the second? That'd be 1. C to the second times what equals c to the third? That'd be c. Then we just got that d to the fourth that we can't do anything with. Plus, then we have 42 times what equals 126? Well, that'd be 3. A times what equals a to the fourth? A to the third. b to the second times what equals b to the third? Well, that would be b c to the second times what equals c to the second? Just 1. So we're done there. So the answer for the factorization of this is 42a b to the second c to the second times the quantity of 2cd to the fourth plus 3a to the third b. So when factoring, you factor each term, split it apart by your constant and then each variable. That's the best way to do it. Once you've got your greatest common factor, you form your parentheses, then you figure out what number of your greatest common factor times what equals the original terms. And that's really all there is to it. So the next lesson is going to be the difference of two squares. There's kind of a shortcut with certain types of problems using the FOIL method. So we'll get to explore those, and I hope everybody has a good night. Take care.